Linear geometry, we're doing a series on writing proofs. I'm trying to go back to the bedrock basics and just brick by brick, we're building a foundation here for you to do proofs, okay? So we've started looking at algebra. We have now graduated on to looking at geometry. We looked at line segments last time. And what I told you in the last one is that it's often hard, especially at the beginning of doing this, you're used to manipulating numbers, you're used to manipulating variables, but it takes a little bit of practice to manipulate geometric figures and segments. And then today we'll talk about angles, okay? Once you get it though, it really shouldn't be any harder than variables or numbers. So let's talk about angles today. And you know that one of the basic postulates you're going to use here is the angle addition theorem. Just kind of like in the last one, you used the segment addition theorem, or the segment addition postulate, sorry. So it's the same premise, is that if you have two angles, you can add them together to make a bigger angle. So let me give you a figure. I just kind of made this up out of thin air, and I hope this is visible to you all. Let's call this A, B, C, D, E. So here's what I'm going to give you. Can I write this over here so I have room? Let me try this. Given, let's say that this big angle, ABD, is congruent to this big angle, CBE. You are going to prove that these two smaller angles are equal to each other. Sorry, I forgot the angle sign. Prove that angle ABC is congruent to angle DBE. So what I've been encouraging you to do at this point is to just take a moment and try to get this in your head. Now, sometimes it's easier when there's a drawing like this to kind of mark it up a little bit. So what I have told you is that this angle is congruent to this angle. And you're trying to prove that this smaller angle is congruent to that smaller angle. So my strategy when I look at this is I can see, okay, if these two angles are equal, and, I'm sorry, not if they're equal, if the bigger angles are equal, they both include the center angle. I don't know what color I'm going to use for that. I guess I'm going to use blue again. But basically this angle plus this angle equal that angle plus that angle. So if I could just take that and subtract out the blue angle, then I'm going to leave these two that are going to be the same. So that's my strategy when I look at it. Okay, that's where I'm going to want to go. So now I need to do a little manipulation of these things, and that's the basics of doing a proof. So we have statement, we have reason. Number one, angle ABD is congruent to angle CBE. The reason is given. So now what I want to do is I want to show that this big angle is made out of these two smaller angles. So angle, hold on a moment. Remember that when I'm trying to manipulate things, I can't switch between congruency and equals without saying that. I can't just flip it around. If I'm going to start talking about things being added together, though, I need to not be in congruency. I need to be in an equation form. If you're adding and subtracting things, that's an equation kind of system. So the first thing I have to do is change this to measure of angle ABD equals the measure of angle CBE. And that is the definition of congruency. Is that visible on camera? So now what I want to do is I want to talk about the fact that this bigger angle is made up of these two smaller ones. So the measure of angle ABD is the measure of angle ABC plus the measure of angle, ooh, this is not going to fit on there, CBD. I slopped over a little bit. And let me do the same thing with the other angle, and it's going to be the same reason, so that's why I'm going to do it now. So the bigger angle here, or the other angle, the measure of angle CBE equals the measure of this one, measure of angle CBD plus the measure of angle DBE. I think sometimes what kind of gets your brain going is, we have to name 3 letters to talk about one unit. And in algebra, we use one variable. So it takes a little practice, and you just gotta remember kind of what you're doing. I'm talking about this angle and that angle, even though I know it has a bunch of letters involved. So now, what's my reasoning for this? Like I just told you before, you're going to use a lot of this, the angle addition postulate. All right, so remember my strategy? I was going to show that this is made up of these two, this is made up of these two, and then if I could subtract out the common one, I'm left with the 2 on the edges. So I want to subtract out, you see that there's CBD and CBD there. First though, I have to put these, I have to kind of link these together somehow in one equation. Because I have 2 equations, I can't subtract between those. Does that make sense? So if I know that ABD is the same as CBE, I'm going to just sub out here. And so instead of CBE, I'm going to put in ABD for a moment. So step 5, the measure of angle ABD equals these two, measure of angle CBD plus measure of angle DBE. And what property is that? Now, remember, I have one entire side here is CBE. One entire side is CBE, so that's a clue that's going to be the transitive property. Transitive. And that is steps 1 and 4. So now, I have a way to link these two together because they both equal ABD. So again, I'm going to use a transitive property. I'm going to link these two with those two. So this one, the measure of angle ABC plus the measure of angle CBD, I can tell I'm not going to fit this on here, equals the measure of angle CBD plus the measure of angle DBE. And again, sorry this is getting messy, that is the transitive property, because remember, they both equaled ABD, so now I can just cut out ABD. This is the transitive property, and what steps is it? It's step 5 and step 3. 3 and 5. Is that visible on camera? Ooh, kinda. 3 and 5. Make sure you annotate what steps you are using. So now I have these linked together. And do you remember my strategy? After I showed that this angle was these two, this angle was these two, if I subtract out that one, so I'm going to subtract out CBD from both sides. So, step 7. Ooh, this is going to be a long one. I'm going to try to write this kind of small. Measure of angle ABC plus measure of angle CBD minus measure of angle CBD equals measure of angle CBD minus the measure of angle CBD plus the measure of angle DBE. I barely fit that on there. Now I barely have room. So if you're doing this on your paper, maybe just, I'm running out of room here on my board. So you could just carry this down and make this like 2 parts here. I'm just going to cram my reason in over here, if that's okay. So this is measure, did I get off on my numbers? 4, 3 and 4. So this is angle, this is reason 5. And this is reason 6. And now this is going to be reason 7. And it is just simply the subtraction property. All right. So now if I simplify, I'm almost there. Step 8. Measure of angle ABC. Now this minus that just goes away. Equals. This minus that goes away, and I'm left with the measure of angle DBE. And the reason for that is simplify. And you're almost home. You got the measure of the angles you want, but you want to prove that the angles are congruent. So now we just have to switch back to congruency. Angle ABC is congruent to angle DBE. That's what you wanted to prove. And number 9, that is the definition of congruency. Okay, I'm sorry that is messy. I'm hoping you can see all that. That is the way you would use angles, and it's exactly the same format as you would use for segments. Remember that when you switch between congruency and equals, you have to state that in a definition, and then you can switch back at the end. Remember that 2 segments add together to make a longer segment. 2 angles likewise add together to make a bigger angle. You can add or subtract those things. So I'm hoping you see the similarities there. And likewise, we can even link these 2 things back to algebra. We do the same things with algebra. It just looks a little bit different. So I'm hoping that made sense. You can practice a few more of these. And we're going to do, I think, one more tomorrow. And we'll talk about some special angles. Okay? Because that's what we talked about a lot at the beginning of this book. And I'll see you tomorrow. Okay?